right, guys, we get to the fun stuff today. All right, so we are going to add to our notebook today changing roots to exponents and vice versa. This is where it gets good. And all these little hints that I've been dropping along the way where it's like, well, we can't do this yet. We can't do this yet. Now we can do it. Okay, so let's turn to page 75 and 76. Okay, so 75 here and 76. And on 75, I'm going to put this big one here. That's kind of folded like a backwards book, just in case. And then on 76, we're going to put this little card at the top, and then we'll put the book underneath that, the magical book underneath that. Okay, so basically, if we did the lab in class today, or if you do the attached lab to this assignment here, this will really help you to see this relationship. But basically, out here we have our index. So I'm going to call that I for index. And then all numbers and letters have exponents. So I'm going to call this E for our exponent. So basically, if I have a root with an index and then a number under with an exponent, which I always do, I can change this to something without a root, and I can just change it to an exponent. So, excuse me, what happens is your exponent stays on top and your index goes to the bottom. So exponent is on top, index on bottom, which should make sense because exponents are going to make me larger, and if it's a numerator, it's getting bigger. Indexes are going to make me smaller. Indices are going to make me smaller. And when I'm dividing by things, I'm getting smaller. So hopefully that kind of makes sense. Okay, now we're just going to do a billion examples. Okay, so let's actually jump over here for a second because these ones are going to be pretty straightforward. So like if I have the square root, that's the same thing as being to the 1/2 power because the exponent here is 1. Our root, if we don't see it, is always 2. So for instance, if I'm looking at the square root of 49, I could really write that as 49 to the 1/2 power. And we should know that either way, it's 7. If we're looking at the cube root of b, that is b to the 1/3 power. If I take the cube root of 64, we should know that that is the same thing as 64 to the 1/3 power, which is 4, either way. Okay? We got a 4th root. We can change that to a 1/4 power. So the 4th root of 81. Remember, 4th root is kind of like square rooting twice. I can also write this as 81 to the 1/4 power. And so if I square root that once, that's 9. If I square it again, it's 3. We can even do a 5th. So the 5th root of b, or to the 1/5 power, we could do something like 32 with the 3 to 32. So that would be the same as 32 to the 1/5 power. And I'm pretty sure that's 2. Yeah, 2. And we can do the 6th and like so on and so forth. So like the 6th root of 64, for instance, would be the same as 64 to the 1/6 power. And that would also be 2 because we got one more 2 here. And 2 times 32 is 64. But you can also do it with like different exponents. So like if my exponent is 3 and my root is 2, remember exponent stays, root goes under. And so if I had the square root of 9 to the 3rd power, I could also write that as 9 to the 3/2 power. But in my brain, I'm just thinking about how I'm taking the square root, and taking a root is always better to do first. Like if you can take the root, you should try to do it because the root will make you smaller. Then you can raise it to the power. So taking the square root of 9 is 3, and then 3 to the 3rd rather is 27. So it's like I did the square root and then I raised it to the power. Okay. Another example of that could be if I had a cube root of maybe 64 to the second power. I could rewrite that as 64 to the 2/3 power. I'm going to try to take the root first, and I can take the cube root of 64. That is 4, and then it's squared, so 16. We could do it with a larger one. So if I had the cube root of 8 to the 4th power, that would be the same as 8 to the 4/3 power. But again, I'm going to take the root. So cube root of 8 I can do, that's 2 to the 4th power, I believe is 16 again, right? Yeah, 2 times 2 times 2 times 2. We could do it here with a larger root. So if we had the 4th root of 16 to the 3rd power, I could also write that as 16 to the 3/4 power. So we're taking the 4th root of 16, which I can, that's 2 to the 3rd, which is 8. I could go even bigger. So if we had the 5th root of 32 to the 2nd power, we could really call that 32 to the 2/5 power. So the 5th root of 32 is 2, squared is 4. So I'm always doing the root first if I can, and then raising the power after. Okay, so now we just got a bunch of examples down here. So, you know what, I'm going to come back to these. I'm going to maybe come back to these because we did a lot of those. Let's jump over here because I think these ones are a little bit more fun. Okay, so let's look in our book. First, we're just going to practice rewriting. Okay, so right here, if I rewrite this, right now it's a root, so I want to rewrite 63 to a power, and 3 is the power, 5 is the root. So you're just rewriting. I don't think I even can evaluate here, like the 5th root of 63 is not a thing. Same idea here, we're going to take our negative 25 and just rewrite it. So 4th power, 3rd root. Can't take 3rd root of negative 25 anyways, so we're just rewriting. And then right here we got 124 to the 7th power, the 6th root. Can I take the 6th root of that? No, I cannot. So I'm just going to leave it. Here we are also going to rewrite. So right now I have a fractional exponent, so we're going to rewrite that as a root. And so I write down my negative 57. I'm going to put a root around it. And the root that I want is 3. And then to the 4th power. Now, it doesn't matter to me. The 4 can go under or outside of your root. It really doesn't matter. It means the same thing. Okay, so next we have 13. We're going to put a root around it. The root we want is 2. So you can put the 2 or not. It's implied that it's 2 if it's not there. And then we're to the 3rd power. And again, I'm not going to do these exponents because like that's ridiculous. I'm not doing 57 times itself 4 times. And then 204, we're going to put a root around it. The root I want is 8. And then to the 5th power. All right, let's try one more. Ooh, evaluate without a calculator. This is the fun stuff. Okay, so we're 36 to the 3/2 power. The root is 2. So that's 6. To the 3rd power is 6 times 6 times 6. That's 216. I'm going to rewrite this fraction straight up and down. So 64 to the negative 1/6 power. I know there's a negative there and it's not supposed to be. I'm going to deal with it in a minute. I'm going to just worry about the root in the exponent for now. So the 6th root of 64 was 2. To the negative 1st power is not allowed, and so I have to move the 2 to the 1st to the bottom, so 1/2. Okay, same idea here. I'm going to rewrite this 16 to the negative 1/4. So I'm taking the 4th root of 16, which is like taking a square root twice. So now we're 2 to the negative 1st, which is again is 1/2. Because we're like moving it to make it positive. And lastly, we have 8 to the 4/3. So we're taking the cube root which is 2 to the 4th power, which is 16. And here we go, evaluate with a calculator. No, thank you. No, thank you. I don't want to use a calculator. Let's go back to some of these. So there are a bunch of examples in here, guys. I'm not going to do all these. I will probably do a few, and then hopefully I'll be good. So practice translating. So we're just going to rewrite the form that we're in. So right now we have an exponent, so we're going to make this a square root of 14. This one is a good one though, because really the only thing that has the half power is the x. So if I was chilling, x is in a root, and the square root to the 1st power. Same thing with this one, like 17 is just chilling. It's not, it has an exponent of 1. It's not in a root. The y, however, is in a cube root to the 1st power. Okay. Here we go. Right over here, we're going to rewrite that as the cube root of x to the 1st. Okay, here's another good one. So 19 is to the 1st power. A is to the 1st power. Both of those are not in roots because they don't have denominator powers. So just 19a is chilling, but b does have a root because it's got a denominator, and it's the square root to the 1st power. Thankfully here we only have one number, so y to the 1/4 power, because it's 1 and then the root is 4. Here, both of these numbers are under the root. So one of two ways to write this. We can do 12n to the 1/2 power, because they are both to the 1st power and they're both under a square root. Or we can write it individually. So like 12 to the 1/2 and n to the 1/2. I feel like either way is correct. So whatever you feel more comfortable with. We got the cube root of b. We're going to rewrite that as b to the 1/3 because the exponent is 1. The root is 3. Here we got 37 to the 1/2 because the exponent is 1 and the root is 2. All right, I lied. These are fun. I'm going to keep going. So if I simplify over here, I'm taking a square root, that's 7. Square root, that's 5. Cube root, that's 3. Cube root, 4. Square root, 10. 4th root, which is like taking a square root twice, so 2. Square root, cube root, root, square root. Easy. Let's go down to the more challenging stuff. So I'm not going to rewrite these in any form. I'm just going to evaluate them. So like here, oh, maybe I can't. Oh, I can't because I can't take the square root. And if I can't take the square root when I cube it, I'm not going to be able to square root it either. So we'll just rewrite it. We're going to rewrite this as the square root of 14 to the 3rd. Which maybe could be argued. There's a group of 2 in there. So maybe I do want to take a 14 out and leave a 14 in. Maybe that's better. I don't know. What do you think? Here the 5 is not in a root because it does not have a denominator exponent. So 5 is outside, but then the x is inside of a square root with a to the 3rd power, which again, I kind of have a group of 2 there. So I feel like I want to do 5x root x. I feel like that just feels more right to me. I don't know. Same thing with this one. So 17 is outside of a cube root y squared. Now there's only 2 there, so I can't do another simplified thing. I'm just going to leave it like that. Here we're going to rewrite this as the cube root of x to the 4th. And I kind of do have a group of 3. I feel like I'm going to take one out and leave one in. That just feels more right to me. Now on this one, the 19 and the a are not in a root. They're outside chilling. But the b is in a root because it has a denominator exponent, a square root, and then b to the 5th. Which, I mean, I kind of have 2 groups of 2 there. So I think it feels more right to me to take 2 b's out and leave 1 b in. This one I can rewrite as y to the 3/4 power. Down here, all these things are being square rooted. So like I kind of need parentheses to show that the 12 and the n are both to the 3rd power and both being square rooted. Or again, we can distribute it. Either way feels correct to me. So I don't feel that urge to like distribute like I do on these ones to like simplify the root. This is fine, I think. Okay, so here we have b to the 2nd and then the cube root. And here we have 37 to the 5th and then the square root. Alrighty, let's evaluate some. Here's where I really get into it. Okay, because I always like to take my square root if I can, and I can. It's 7, to the 3rd. Just 7 times 7 times 7. Oh my gosh, I do not know. Calculator. 49 times 7 is real big. 49 times 7. 343. I knew that. Okay, 25 to the 3/2 power. Well, I'm going to take the square root and then cube it for 125. Next, I have a cube root. So cube root of 27 is 3 to the 2nd is 9. Here I have a cube root. So cube root of 64 is 4 to the 2nd, which is 16. 100 to the 3/2 power. So square root is 10 to the 3rd is 1,000. Which, like, again, these kind of make sense. So like when I look at this, the 64 got smaller and that fraction is smaller than 1, so it should get smaller. Here I was 100 and got bigger, and that makes sense because my fraction is bigger than 1. So smaller than 1 you're going to get smaller, bigger than 1 you're going to get bigger. I hope that makes sense. I think it does. So here we're going to take the 4th root of 16, which is 2, to the 3rd, which is 8. Like, I don't necessarily have to rewrite it. I can just do it. Like, same thing here. The square root of 144 is 12. Squared is 144. LOL, that seems silly. Cube root of 125 is 5. Squared is 25. And square root of 64, those square root and square are just going to cancel out for 8. LOL. Sorry. Okay. That's too much fun for me. I love it. We'll see you on the next one.